This is an example video for the topic, Rewriting a Quadratic Function to Find its Vertex and Sketch its Graph. In this video, we will rewrite the quadratic function g of x equals 2x squared minus 4x plus 7 in the form g of x equals a times the difference of x minus h squared plus k. We'll then find the vertex of its graph and then graph the function. The first step is to make the coefficient of the squared term 1. To do that, we factor 2 out of the first two terms. Next, looking at the terms in parentheses, we complete the square. To do this, we first divide the coefficient of our second term by 2, and then square that number. And we finally add that number inside the parentheses. Now we've added 1 inside of the parentheses. If this 2 were distributed to each of these terms, the term plus 1 would be plus 2. So since we've added 2 to the right side of the equation, to compensate, we'll also add 2 to the left side. Now we can subtract 2 from both sides of the equation. And finally, since we completed the square inside the parentheses, we can rewrite this expression as x minus 1 squared. The minus 1 came by dividing the coefficient of x by 2. Now our quadratic equation has been written in vertex form. At this point, we're ready to graph this function. The reason we rewrote it in this form is that now we can more readily find the vertex of the graph of this function. The x value of the vertex is the number that is subtracted from x inside parentheses. So in this case, it's 1. The y value of the vertex is the number that's added outside of the parentheses, which in this case is 5. Now we know that the point 1, 5 is a point in our graph, and it's the vertex. To find some other points on our graph, let's choose some x values greater than 1 and less than 1, and plot those as well. Here we've chosen x values -1 and 0 less than 1, and 2 and 3 greater than 1, and we found the corresponding y values by substituting those x values into the function g of x and evaluating. Next, we're ready to plot each of these points, starting with the vertex at 1, 5, and then our other points, -1, 13, 0, 7, 2, 7, and 3, 13. If we connect these points with a curve, we've now formed our graph. At this point, we've written the equation in vertex form, found the vertex, and graphed the function.